All right, thank you very much, Rosemary, for the introduction. And hello, everyone, and thank you for joining us for the next hour. I am Danny McBride with the U.S. Environmental Protection Agency's Energy Star program. This is the second webinar of a three-part series on America's most energy-efficient manufacturing plants. And if you're just joining us, there is a trivia question to the right-hand side, which is asking you to guess how much energy it takes to refine a barrel of oil and to manufacture a ton of paper. So I'm asking you this question because today you're going to hear presentations from one of the most energy efficient petroleum refineries in the country and one of the most energy efficient paper mills in the country. So I'll give you a few more seconds to take a guess with that poll. All right, and why don't we close the poll now, Rosemary, and show the results. Let's see what people think.
Right. Experiencing some technical difficulties on my end, so once it loads, then I will share the results. Okay.
Well, while we're waiting to see what you think, I will actually give you the answers. So it takes about 600,000 BTUs of energy to refine a barrel of oil. And we just have the results coming up now. And actually, of the people who responded, most people thought that that's what it takes. So good job. And for manufacturing a ton of paper, most people thought that it takes about 750,000 BTUs, but it's actually a lot more. It's between 6 and 9 million BTUs to manufacture that amount of paper. So let's put that in perspective. Everyone here has boiled a gallon of water before, and it takes a little over 1,000 BTUs to bring room temperature water to a boil. There are 42 gallons in a barrel of oil. So even if you're going to boil 42 gallons of water, that's still 10 times less than the amount of energy it takes to refine a barrel of oil. The tons of paper, they're in different units, so it's hard to compare, but that's still a lot of energy. And that is why we focus on plants. We focus on plants because it takes a lot of energy to manufacture different kinds of industrial products. And in the US, the manufacturing sector consumes more energy than we consume in our homes, than we consume at work or when traveling. And because energy use is also highly correlated with greenhouse gas emissions, it's no surprise that the industrial sector also accounts for 1/3 of greenhouse gas emissions in the country. Now, not all refineries and paper mills will use the same amount of energy to manufacture their products. Some are going to use more, some are going to use less. And at Energy Star, we consider the plants that are in the top 25%, the top quartile, to be the most energy efficient in the country. And our speakers today are going to talk about what they did to get to that level of achievement. But first, you may be wondering, how does a plant know if it's in the top quartile of efficiency? How does EPA know what those plants are? So Energy Star has benchmarking tools for nearly 20 sectors called energy performance indicators. And these are going to tell plants how efficient they are compared to similar plants. All these EPIs are downloadable in Excel. In fact, if you go to energystar.gov/plants, you could download one for your sector if it's up here. For refineries, Energy Star actually recognizes a third-party tool for benchmarking. Here's a snapshot of one of the EPIs for an integrated paper mill. And the way it works is plants are going to enter energy and production data for a 12-month period. And then the EPI is going to calculate approximately how much energy a plant with those characteristics would use. So in this case, it's saying this plant with this level of production will use about 7.5 million BTUs of energy. The EPI is then going to give the plant a score from 1 to 100 that says how efficient your plant is. So in this case, because this plant is using less energy, about 6 MMBTU, it has a score of 78, a score higher than 50, which is the average. And this plant and these EPIs are based off of an underlying statistical model that uses energy and production data from the industry to calculate, to predict how much energy a plant would use. And plants that score a 75 out of 100 or higher are able to get Energy Star certification. In order to do that, they have to submit an application, they have to get a professional engineer to validate the data, and they would need to reapply annually to demonstrate that they are still in the top quartile. Now, there are over 230 Energy Star certified plants across the country in 20 sectors. And today we're going to hear from 2 of those plants. We're going to hear from Marathon Petroleum's Robinson, Illinois refinery, which has been certified for 6 years. And we're also going to hear from Georgia Pacific's Brewton, Alabama integrated paper mill, which was certified for the first time last year. Joining us from those organizations will be Jason Akey, the corporate energy technologist, and Barrett Von Baron, the energy and sustainability coordinator for the Robinson refinery. They're from Marathon Petroleum. And also joining us will be Mike Eunice, who is the Director of Energy Optimization for Georgia Pacific. So during the presentations, I would encourage everyone here to listen to what these plants are doing to improve their performance. A lot of what they're going to talk about is going to be transferable to other industries. While they may talk about technology specific to refineries and pulp and paper mills, a lot of what they're going to talk about is energy management, which could be applied across the manufacturing and commercial building sector. So with that, I'm now going to turn it over to Jason Akey to talk about what the Robinson, Illinois Marathon Petroleum Refinery has done to reach the top level of performance. Jason.
That's a great lead-in, Danny. Appreciate it, and thank you. And thanks to all of you for listening in on this Energy Star webinar on America's most energy efficient plants. As Danny mentioned, I am Jason Akey. I'm the energy technologist for Marathon's refining division. I'm based out of the St. Paul, Minneapolis area. I'll be covering a couple of slides before handing it over to Barrett, who's our sustainability coordinator. And for you, sustainability at Marathon in the refining segment primarily means energy intensity and water intensity reduction. So those are his primary responsibilities. A few data points about Marathon. We are the largest U.S. refiner with nearly 3 million barrels a day of capacity. And if you paid attention to the poll and heard that 600,000 BTU per barrel number, that would tell you that our energy consumption as Marathon is somewhere near 2 million BTUs per day. Obviously an energy intense business, and we're going to talk to you about all the things we do at Robinson to minimize that to the extent we're able. We have 13 refineries across 12 different states. So you can see our assets are coast to coast. If you are driving a petroleum-based fuel vehicle, you at some point have probably purchased gasoline that's come through a Marathon facility. Regarding Marathon sustainability initiatives, well, one, kind of accreditations, we are very proud to be an Energy Star Partner of the Year. Since 2018, this past year was our first year to achieve sustained excellence, and that accreditation has really allowed us to gain more momentum within the organization and the importance of our Energy Star partnership. In terms of facility certifications, we do have 5 facilities that were certified in 2020. 2 of them have been certified ever since Energy Star recognized petroleum refineries. So for context, this is about 40% of our refining fleet, meaning that 40% has achieved the top 25% in performance. And we're getting close to having one or two more achieve eligibility. So looking forward to continuing that partnership and goal. Our stated greenhouse gas intensity goal is to have a 30% reduction in greenhouse gas intensity by 2030, and energy efficiency is a very important component of that. Thanks, and I'm going to hand it over to Barrett to provide details on how Robinson's site culture, management support, and innovative ideas have helped them maintain Energy Star performance.
Hey, thanks, Jason, and thanks to Energy Star for the opportunity to present today. This is something we're extremely proud of at our facility. We value the Energy Star certification, and I'm happy to present on it today. So just a little bit about the Robinson refinery. So where are we? We're located kind of amongst the cornfields in central Illinois, about 4 hours straight south of Chicago, a couple hours west of Indianapolis. Our claim to fame is actually we're the home of the Heath Bar. So getting ready for the holiday season, if you're going to a gas station or a grocery store and you pick up a Heath Bar, that was manufactured here and invented in Robinson, Illinois. So our plant was constructed in 1906 by the Lincoln Oil Company. There was a large oil boom in this area around the turn of the century, and hence the need for a refinery here. We cover nearly 1,000 acres, have a little over 700 employees, and we process over 265,000 barrels per day of crude oil. So we're about a fairly large refinery in terms of capacity. And we operate 365 days out of the year, 24/7 operation. We only shut down if we conduct some type of maintenance activity, and typically that's only a portion of the plant. So to kind of put things in perspective, I know it's hard to quantify our capacity, but we produce over 6 million gallons of gasoline here on a daily basis. And that's enough fuel to fill up over 300,000 automobiles each day just out of our facility here in Robinson. And like I said, something we're extremely proud of here is we are a 6-time Energy Star certified facility. So high-level overview for those of you that aren't familiar with the refining process. So on the left-hand side of the screen, just kind of a life cycle of a barrel of crude oil. Comes out of the ground. Marathon, we don't drill or extract any oil ourselves. We purchase that, bring it to our refineries on our extensive pipeline network, process that barrel of crude oil, and then ship it to our terminals and ultimately to you, the consumer, to put in your car to travel for the holidays, get to work, etc. On the right-hand side is kind of a simplified diagram of exactly what a petroleum refinery is. So when a barrel of crude oil comes out of the ground, it has a wide range of molecules in it. Some of the lightest molecules are propane, butane, and then we start to get heavier, such as gasoline, kerosene, jet fuel, diesel fuel, heavy oils, and even asphalt. Marathon is one of the largest producers of asphalt in the United States. And kind of over on the right-hand side of the diagram, there's a handful of auxiliary units in a refinery. So distillation is the key here. We have hundreds of distillation columns. We also have processes that rearrange molecules, remove impurities, that sort of thing. So the energy in refining, so as the poll said, 600,000 BTUs per barrel. I've quoted 400,000, but nonetheless, multiply that over 265,000 barrels per day, and it's a large number. And a lot of that comes from, we're taking crude oil from ambient temperatures, comes out of a pipeline into a storage tank, plus or minus 50 degrees Fahrenheit, and heating it up to over 700 degrees to get it to boil. We do this through extensive furnace networks here at our facility that use natural gas. We do produce some ourselves. We also import a large amount. We have power boilers here that generate steam as a heat source. And then we have a vast heat recovery system to recover waste heat and put that back into our process. So as I mentioned, and those of you familiar with distillation, we're heating oil up, getting it to boil. And that takes heat, but then subsequently we have to cool it back down into a liquid and transfer it from one point to another. And that takes electricity, and that's cooling fans, and that's pumps for cooling water. We also have a wide variety of chemical reactions that take place here in our site to rearrange molecules. Some of those require heat, and some of those require us to remove heat. And then we have thousands of pumps and compressors to transport those commodities across our 1,000-acre complex here in Robinson. And I mention all that to touch on the importance of our MPC's energy culture. And I'm going to talk a little bit today about the pillars of that culture here at our facility. Communication, above all else, is key, and that's KPI, key performance index monitoring and reporting, and being as transparent as possible. Also, it's maintaining annual energy reduction initiatives and programs, capital project brainstorming and implementation, and because it's so important, I mentioned it again, communication is what bookends all of this. The slide I have on communication really talks about some of our KPIs and our reporting. So my job here at the facility, I'm our site energy and sustainability coordinator, and my role is to shepherd the program, track performance, and then report on that. So I have monthly reporting to site leadership here. We also have a quarterly deep dive session where I'll sit down with the management here at our facility and evaluate our energy performance over the past quarter. Now, data is great, but we have to get data to the decision makers, and that's what we've worked hard here at our facility, is getting data to the front lines, to the actual operators that are optimizing furnaces, turning valves in the field. We can talk BTUs, we can talk kilowatts all day, but ultimately what impacts decisions in the field is dollars, is money. Show me the money. So here at Marathon, we have a robust KPI tracking system, and we call it our Focus on Energy program. And this is something we have rolled out across our fleet of refineries. Here at Robinson, we have over 70 variables that are tracked in real time. They include anything from furnace optimization to steam consumption to recirculation rates to electricity usage. Ultimately, these are tracked and benchmarked in MMBTUs or kilowatts, but then they are converted to dollars per day. What you see at the bottom of the screen is a couple screenshots of our KPI tracking program. This is from a Tableau dashboard that's web-based. It's easily accessible by all of our team members, and we've rolled this out at all of our refineries. We can track metrics by type, by location in the plant, and we can trend performance over time. And this is ultimately how we get the data to the frontline decision makers to drive improvement. Another aspect is energy reduction initiatives and programs, and I want to talk a little bit about the annual programs we have here ingrained in our culture. One of them is our compressed gas audit, and I heard a lot of this a couple weeks ago on the Energy Star Industrial Roundtable discussion. A lot of folks have taken an interest in compressed gas systems. Here at Robinson, we utilized a third-party contractor to conduct a leak survey at our plant, and we identified over 1,000 CFM of compressed air leaks. These leaks were readily fixed, and it allowed us to reduce the need for portable air compressors and saving us over 1,000 metric tons of CO2 per year simply by tightening up our compressed air service. Since then, we have purchased a couple of the fluke leak detection cameras here at our site and are working to roll out and train our operators to be able to use those in real time to track leaks inside the plant. Another one of our annual programs is our steam trap survey. Annually, we conduct a survey of over 7,000 traps here in our refinery. And I'm proud to report that our refinery has less than 5% trap failure rate. And we have reduced our failure rate by 40% year over year. And I truly credit this to operator perform maintenance. Here at Marathon, we empower our operators. If you see it, you own it, and being able to drive change in the field. So what's that mean? If we encounter a failed steam trap, most of our traps are all quick connect. We either keep those traps in our warehouse or on the operating unit, and it's easy for our operators to swap those out and make those repairs. And that saves us 15 million BTUs per hour, or 8,000 tons of CO2 annually. And the last program I want to touch on, and regardless of your industry or even your house, this is something we can all get around, and that's insulation. Here at Robinson, we maintain an insulation program as part of our annual maintenance budget. We identify areas of the plant as focus areas, and each year go out and tackle a different area of the site to make necessary repairs or replacements of insulation. Common themes that we see here at Robinson, which you may see at your plants, insulation that has been removed because equipment has gone through maintenance or repair. So I have a picture at the top right of the screen of a heat exchanger here at our site. This particular exchanger was put through maintenance. The end of it was removed and the bundle was pulled out and cleaned and placed back in service. Now, oftentimes we want to get these pieces of equipment back in service very quickly, and sometimes we forget to get the insulation or put the coat on when we're done. So that's a focus area. And then also down at the bottom is a picture of a piping circuit here in our plant. And we have a robust corrosion monitoring program here at our facility where we take thickness readings of piping. And you can see here we have over 10 different holes in this insulation jacket to take thickness readings. These particular ones are not plugged or capped. Doesn't sound like a lot, but you figure thousands of these across the site, and those losses add up over time. So this is an instance here where it may be a better fit to put an insulation blanket or jacket here where we can just peel that back and do our survey and place it back without damaging the insulation. But all of these programs annually save our facility over $2 million per year. Also, it's integral to embed energy projects into your capital project portfolio. Our corporate leadership team has tasked each refinery to develop 2 sustainability projects annually in our budgeting process. And that places an emphasis on Energy Star, both at the corporate level and at the site level. Our energy projects have a lower hurdle rate, lower IRR than competitive projects, so it drives investment. Any major project, multi-million-dollar revamp we do at any of our facilities requires an in-depth energy analysis to identify possible optimization opportunities. Common themes we see with our capital projects: waste heat recovery and optimization, minimizing redundant cooling, and technology upgrades. And I hit on technology upgrades. Oftentimes I hear on our site we are going to replace something in kind. We have a heat exchanger that's reached end of life, and we're simply going to replace it in kind. Well, I challenge our team to go look for improved technologies. Should we consider a plate and frame? Should we consider a high conductivity bundle? Look for new and improved technologies that can improve energy efficiency. One of the projects I want to highlight we have here at our site is preheating boiler feed water. So I'm sure most of the industrial users here on the call have power boilers at their site. Here at Robinson, we have a couple that generate 600-pound steam. We utilize low-pressure steam to deoxygenate or deaerate that feed water. Subsequently, we also have a unit here at Robinson that produces diesel fuel for trucks, tractors, etc. The diesel is cooled from 200 degrees Fahrenheit down to 100 or less to tankage. It's cooled via fin fans or air coolers and cooling water exchangers, so that heat is simply lost to the atmosphere. We have initiated a project to install a 35 MMBTU per hour plate and frame heat exchanger to recover that lost heat and inject it into our boiler feed water to preheat it. And this is projected to reduce our carbon footprint by over 17,000 metric tons of CO2 per year. And that's the equivalent of over 90 rail cars of coal burned when you use Energy Star's CO2 equivalent calculator. This is simply a high-level schematic of the process. At the very top, we have our condensate being returned to our boiler house. At the bottom, we have our finished diesel that's being cooled, and we're installing our 35 MMBTU per hour exchanger. So this is the last slide I'll leave you with and the summary of our program. We're very proud of Energy Star here at Robinson, not just at the site, but in the community as well. And it's based on a culture of sustainability and energy efficiency. It doesn't happen overnight, and in fact, it can't happen overnight. You don't want it to. You want it to build over time. Go slow. Communication is key. Get data to the decision makers. That's from the front office to the front lines. You must have leadership support. And the last key is maintain annual programs and project development. I use the snowball rolling down the hill analogy. It's hard to get it started, but once you do, you can continue each year. It's going to grow, and it's easier and easier to build out those programs and drive energy efficiency. And the picture here is of our trophy case we have here at our site where we showcase our Energy Star awards. So with that, I want to thank you for your time, and like I said, I'm very proud of our facility, and it's an honor to be here with Energy Star today, and I'll turn it back over to Danny.
Well, thank you very much, Barrett and Jason, for a really detailed and great presentation. So a few things that I heard from you is what you're doing at Robinson, it's a combination of capital projects and really great energy management programs. So you gave the example of recovering waste heat from a boiler. I remember you said when you are looking for replacements or optimization, don't just replace in kind, look how you could optimize it. But you were also talking about when you're looking at for failed steam traps or compressed air, you weren't just doing this one time. You had programs about it, meaning that you are doing this continually. So I think this really goes to show how important have energy management and continuous improvement and empowering your employees are in achieving and maintaining top performance. All right, so if you do have any questions for these guys, put them in the chat. We're now going to transition to our next presentation. So again, Barrett and Jason talked about energy management. And one thing I want to say at Energy Star, we have tools and resources to help companies in their energy management journey. So we're next going to hear from Mike Eunice of Georgia Pacific, and he's going to talk about how one of their integrated paper mills achieved Energy Star certification. Again, that means it's in the top quartile of performance. But he's also going to talk about how that mill was actually in the lowest quartile of performance and how they used the Challenge for Industry, which is another Energy Star program, and a few other things on their road to top performance. Because Mike is talking about this, very briefly, the Challenge for Industry is open to any manufacturing plant. And if that plant is able to reduce its energy intensity by 10% or more in 5 years, it can receive recognition for achieving the challenge. And we do hope that if plants achieve the challenge, they're eventually going to get to the top quartile, which would allow them to be Energy Star certified. So I'm now going to hand this over to Mike Eunice. We're going to go from Robinson, Illinois to Brewton, Alabama, and we're going to see what this plant did to achieve top performance. Mike?
Thank you, Danny. Rosemary, I can't advance the slides.
Oh, let's see.
There we go.
There you go. Okay.
All right. So there are currently 2 pulp and paper mills that are certified. The one I'm going to speak about today is our Brewton plant. And then our Leaf River pulp mill is also certified. And we're very proud of them, and I'm very thankful to all of you for listening in as I get the opportunity to speak about them and to Energy Star for helping us make these plants more competitive. So a little bit about Georgia Pacific. We have 30,000 employees in 180 locations. It's a forest products company. We're in pulp, paper, building products, and chemicals. The chemicals are actually derivatives of the forest products industry. So they're chemicals that we extract from trees, basically. We also have a recycling business where we recycle plastic, paper, and metals. And recycling is a very big part of our business. As a matter of fact, 3 of our very large facilities operate almost exclusively on recycled paper. So a couple of certifications first, the pulp mill. Leaf River was a relatively new plant with a single line design and very disciplined operations. So if they had a good design and they maintained the discipline to run it well, and ultimately they were certified. Bruton, on the other hand, was a different experience. It was a 65-year-old plant where we made a significant capital investment, and then the mill employees made an equally significant investment of time and effort and ingenuity to capture the benefit of the capital investment. So to help you understand what we did in Bruton, I'm going to take you through the paper making process, a thumbnail sketch. Here on the left are where the chips come into the digester. We basically take in a tree, we chip it into wafers the size of a quarter and put it into the digesters where heat and chemicals break it down to extract the cellulose fiber. So across the top is the stream of the chip to fiber on the far right. And for purposes of today, where it becomes really significant is right through here where the liquor comes out of the washers and goes into the evaporators. The evaporators, much like evaporated milk, thicken the liquor to remove water so that it becomes a fuel. And that liquor contains everything that was inside the tree that was not cellulose. So all the other compounds, plus the chemicals that were used to break down the chips, are in the liquor, where we then densify it to remove water and put it into the recovery boilers, where we recover the energy and make steam for our combined heat and power plants, and then recover the chemicals that are then reused to digest more chips. Following the digester, you go into the paper machine. We're going into the paper machine nearly all water. Water is used to convey the cellulose fiber. In the first stage of the paper machine, we drain the water via gravity and then by vacuum, and then it'll go into a series of heated dryers, steam rotary joints, where the paper is in close contact to the dryer to evaporate water, and then ultimately through the calendar stack to finalize the thickness and onto a reel to be processed into other products. So Bruton started up in 1955, or started construction in 1955 and started operations in 1957. And they manufacture paper used in high-end packaging, things like pizza boxes, and also the board used to make Dixie paper plates. Over the years, the plant became less and less competitive. It was too small, and so they added equipment to make it bigger. And you wind up with 3 of everything, and it's very difficult to be competitive when you got 3 very small trains running the product. In 2014, Georgia Pacific excuse me, made a $400 million capital investment in the plant to bring it up to a better competitive position. And then in 2020, we completed the challenge for industry, and then 2021, plant certification. So what was that project? It was called Project Phoenix. So we had Bruton rising from the ashes. It was one large recovery boiler to replace the 3 existing small units with a new demineralizer system to supply water, feed water to the recovery boiler. And that picture on the right, you can see the recovery boiler there above the trees. And like most paper mills, Bruton is located near trees and water and not a lot of people. So this is basically a skyscraper in the middle of the woods. As I mentioned, we have combined heat and power. We use steam to dry the paper, and we use the recovery boiler to generate steam. So we run that steam through a turbine on the way to the paper machine, and here you can see the new turbine being delivered. It was quite a sight in a rural South Alabama to see a turbine of this size being hauled through the town. Then we get to the evaporators. Like the recovery boilers, we had 3 evaporators. They were all very small. And the evaporator basically, it boils away the extra liquid, the water, and it does it through a combination of using steam to create a vacuum so that the water boils at a lower temperature, and also to create the heat to boil the water. So it's more efficient than boiling at sea level, and in our case, this is a very large evaporator compared to the 3 smaller ones. Now, we recognized our compressed air system needed an upgrade, so we installed 4 centrifugal compressors and 4 heat of compression dryers to supply the plant with compressed air. Now, what happened? As you can imagine, when you've got all this new equipment going in, there are engineers all over the place working on their particular project to get it up and running so they can go to their next project. And each of them is doing their best to make their equipment functional and stable, but not to optimize the process as a whole. So in 2016, we started up after Project Phoenix was completed, and you'll see that the energy intensity actually got worse for a couple of years as people that were helping to address issues started leaving and going to other projects, and the mill started absorbing, the mill personnel absorbed the extra workload, and they had all these new systems. And so it took a little bit of time for them to get their sea legs and to start marching toward their ultimate goal. But you can see in 2018, they hit their stride. So the capital project moved Bruton from 4th quartile to 2nd quartile. Then the process improvement team within the mill moved Bruton from 2nd quartile to 1st quartile. And that was the period when they achieved the challenge for industry, the 10% in less than 5 years. And it was also the period where they that led up to their being recognized as the 1st quartile paper mill. So here's some of the work that they did. They automated the turbine generator to optimize overall generating efficiency. And when they did that, it wasn't just to optimize the turbine itself, but also the make versus buy decisions that are made based on the price of power from the grid. The least energy intensive way for most paper mills to operate is to generate all the steam they need to make paper and then put it through a turbine to make electricity, and if they need any more electricity than that, to buy it. With one caveat: all the biofuels that are generated at the mill have to be consumed. So they optimize this generator around the fuel supply, the price of electricity, and the need for electricity to optimize both efficiency and cost of power, total cost of power between purchased and self-generated power. Another opportunity, much like Barrett mentioned, is around the collection, waste heat. So we have a fairly large 23-foot tall hot water tank, and the engineers within the plant looked at, where can we collect streams of hot water that currently aren't being collected and get them into the hot water tank so that we don't have to heat water to be used within the process. And they spent a lot of time in this area, both locating energy sources and then finding ways to get them to reclaim them into the hot water tank. Now with the evaporator ran well. Before the engineers that installed it left, it was running well, it was stable. But what the plant engineers did was automate the wash sequencing that's designed to improve the efficiency and heat recovery. And it doesn't make it more efficient overall. As you operate the evaporator and it becomes a little bit fouled, it loses some efficiency. And the real trick is to optimize when you wash and how you wash to maintain an average efficiency that's as high as possible. Here we have a picture of our site energy leader, Bob Dierks, with our certificate. And then also you see a team, a part of the team that contributed to all this effort standing in front of our challenge banner outside the plant. It was a proud day for the mill. If you know anything about Alabama, you know they love being #1, and they were the first paper mill to be plant certified, so they're #1 in our book. With that, I'll take any questions or that anyone might have for either of us, I think, Danny.
All right, thank you very much, Mike. And again, if you have any questions for Mike or the folks at Marathon, put them in the chat. I'm going to start with a few questions, Mike. So it looks like when the plant was in the 4th quartile a few years ago, it looks like you completed a lot of capital projects during that time. You mentioned replacing a recovery boiler. You said installing CHP, doing work on evaporators. What prompted all that to happen at once?
There was an evaluation done at the mill that recognized their competitive position and the fact that energy was one of the leading causes of their being in the place they were in. And so that analysis, that financial analysis, led to the engineering analysis that developed the plan that became Project Phoenix. So it was really about, we're not competitive, we're not happy with not being competitive, and we're willing to invest to be competitive.
Yeah, so it's really interesting that the amount of money, amount of energy you use actually affects competitiveness.
For the paper industry, energy is our #3 cost driver. It's labor, materials, and then energy.
Yeah. So you mentioned a few projects. The first was, you said that you replaced a large recovery boiler with 3 smaller ones, and then I think you said you replaced several small evaporators with a single larger one. Can you talk a little bit about how going from 1 to 3 boilers was more energy efficient, and the same on the flip side for the evaporator?
Actually, it was 3 small recoveries to 1 large one.
Okay.
And ditto for the evaporators. And basically, like many plants when it was originally built, it was built for a certain volume, and then they saw an opportunity to produce more volume and generate more business, and they added equipment and then did it again. And you wind up with those small, inefficient systems as you grow over the years. And so the real commitment was there's a little bit of safety, if you will, in having 3 small boilers, because if one goes down, you still got 2/3 of your capacity, and you have to be committed to keeping everything running when you replace, 3 small ones with 1 large one.
Yeah. So last question for you, and then we'll go to some more general questions. So it's really interesting. You mentioned after you did those capital projects, the energy intensity, the energy performance of the plant actually got worse. And you showed us a graph that was actually tracking their index, their performance. Can you tell us a little bit about what helped you realize that after you installed these capital projects that your energy was getting worse, and what are some of the things that you did to train the plant engineers or to work with management to really get the most out of your investments?
So we started our energy program in 2010. Mm-hmm. And prior to this project, we had KPIs and KOVs similar to what Barrett mentioned earlier in place that we were monitoring. And we saw what was happening, but we also realized that it was, what we had just done to the mill was very disruptive, and that it was going to take some time to get things, sorted out and on the right track. And so we were well aware that we weren't where we wanted to be even after the project, but we were also confident that we could get there. And Bob Dierks and his team did a wonderful job of identifying, the places like the hot water collection and things like that that they could do to optimize a plant after they got all those new resources to work with.
Great. And sorry, this is a similar question that just came in. So was engineering the only activity you did to turn the culture around, or did you do anything else, buy-in from workforce or with management or others?
Part of our energy program is the energy teams. And over time, our teams have morphed from formal teams that meet and, you know, keep minutes and discuss and then go out and do things, to more like networks of people that are working in their various areas, and they reach out to the leader of the team when they need additional resources or support or information or that sort of thing. And so we had a fairly well-established culture in Bruton that recognized that they needed to be competitive, and they were motivated by their own position in the market to do those things. So we didn't really have to. We had built that before we even, before we invested the capital.
Great. Okay, well, thank you, Mike. Rosemary, let's remove the slides, and we'll go to some more questions for both Georgia Pacific and Marathon. So this, maybe we could start with Marathon first for this. So your plant was certified for 6 years. Can you tell us a little bit about what happened after the plant was certified, maybe the first time and in subsequent years?